Mathematics. All right. Mathematics first starts when we objectively perceive the real world with our five senses. Okay. Then we subjectively abstract the mental image that was formed in the visual cortex and other areas in the brain using words, which are then converted to diagrams and symbols to facilitate the documentation, thus written communication of ideas involving numerical analysis. So in other words, when we observe reality, okay, we form a mental image, you know, in our minds, and then with that mental image, we construct diagrams, and well, normally when we think, we use words. So then what we do normally now is to convert those words to symbols, okay, so that you can make the communication of what you perceive, you know, in an abstract form more efficient. And that takes place a lot when you have numerical analysis. So for example, you have a famous scientist called Isaac Newton, okay? And as the story goes, he sat on an apple tree and, you know, an apple fell down. Well, I'm not too sure it was on his head, but it fell down. And after observing that phenomenon, observing the apple falling from the tree, and with further experiments and thinking and, you know, philosophizing and rationalizing, he, apart from this formula, he also derived other formulas, but he also derived that formula S is equal to UT plus half AT squared, where S is for space, displacement, or spatium in Latin, S for spatium for space, but it's displacement. U is initial velocity. U comes before V in the alphabet. So U for initial velocity, V for final velocity, and T for time, A for acceleration. Okay, so from that phenomenon, real world, he was able to abstract that formula for displacement, you know, or distance travel. And why S? Because of, in Latin now, you know, in those days, they used to speak Latin, and Latin for distance start with S for spatium, so that's why the S, okay? And so that's an example where real world observation, from that you obtain abstract symbolic formulas, okay, for numerical analysis. After, you have Albert Einstein. Albert Einstein, his famous theory of relativity, visualizing the light from a clock and you know, the speed of light traveling from the clock, then he actually perceived this could the implications that if you are to travel with the speed of light, time for you would actually stop. Okay, so from visualizing that phenomenon, he actually derived that formula. Here you have it. Time measured from an observer outside the frame of reference is equal to the time measured from an observer inside the frame of reference divided by the square root of 1 minus the speed of the reference frame squared divided by the speed of light squared. So here it is. T is the time for the observer, which is outside the reference frame, and T sub 0 is for the time of the observer inside the reference frame. So as you can see, V is the speed of the reference frame and C is the speed of light. Why C? Because C, in Latin again, celitras, yes, that's speed in Latin, celitras, C-E-L-E-T-A-R-A-S, so that starts with C, so that's why they use C for the speed of light. And, you know, so therefore now, and 1 minus V squared over C squared, that will always be a decimal, 0 point, because the speed of the reference frame will be less than the speed of light. The speed of light is considered constant, the greatest speed that any object can travel in space. So V squared over C squared will always be a decimal. So 1 minus that decimal will be a decimal. The square root of a decimal is a decimal. So T sub 0 divided by decimal will always be, your quotient will be a bigger number. So that T now will be equal to a value bigger than actually t sub 0, right? In other words, the time of the observer in the moving reference frame is always less, all right, than that of the observer outside the reference frame by a factor of the square root of 1 minus v squared over c squared. Okay, so therefore now, as you can see, t0 is equal to t times, that will be a 0 point. So t times a 0 point will be a value less than t. For example, 5 times 0.5 is 2.5. Okay, 10 times 0.5 is 5. So anytime you multiply a whole number or any number greater than 1 by a decimal, you are getting a smaller number. So the time of the observer inside the reference frame, which is t sub 0, is always less than the time of the observer outside the reference frame. So every person, every object have a different time. So in the time of Newton, time is constant. Everybody have the same time. But in reality, it appears that every object, every person, every particle has a different time because of their motion. Time actually slows down this faster that you go. So here you have two cases that actually shows you the process, the definition of mathematics from the real to the abstract, from the tree and the apple to S is equal to ut plus half at squared, from the light beam coming out from the clock or a train moving from one point A to point B with the speed of light actually happening to t is equal to t sub 0 divided by the square root of 1 minus v squared over c squared. Mathematics from the real, from the perceived real to the abstract imagined. Okay,